One of the most basic things we learn in school is about gravity. We know that gravity is what keeps our feet on the ground. It is what keeps our planets in their orbits. And it is what causes ocean tides and the formation of stars. It has always been described as a force. The force that pulls things together. Well, what if it technically isn't a force? According to one of Einstein's most famous theories, the theory of general relativity, gravity is understood as something that warps the spacetime fabric, causing things to accelerate towards each other. Now, what exactly is the spacetime fabric? We know the three dimensions in our world: length, width, and height. We can see it all around us. However, there is said to be a fourth dimension. This is time. The theory of general and special relativity treats time as a dimension alongside the three other dimensions. Under these circumstances, physicists have formed a mathematical model which includes all three dimensions of space and the dimension of time, the space-time fabric. To put this in simpler terms, you cannot move in space without moving through time. As long as you are moving, time is passing. Therefore, these four dimensions exist, and physicists use the model of spacetime to understand the concept of gravity. The spacetime fabric is often compared to a trampoline with a bowling ball lying in its center, and another small ball away from it. The bowling ball will create a depression at the center, due to its weight. The rest of the trampoline will curve around it. Now, the small ball lying at the end of the trampoline will slowly start to move down towards the bowling ball at the center. There is no real force that's attracting these two balls, it is merely acceleration. So, the trampoline is said to be the spacetime fabric, and the bowling ball lying in the center is an object with mass. So technically, gravity is actually a curvature of spacetime rather than a force. To understand this concept a little bit better, we can look at the Earth and the Moon. We know that the Earth is a lot bigger than the Moon and has a greater mass. Therefore, it can be referred to as the bowling ball which bends our spacetime fabric. We know that the Moon orbits our planet, and now due to the warp created by our planet, it travels along the bend. There is no actual force that is pulling the Moon to our Earth. It's just a distortion in our spacetime fabric causing the Moon to follow a certain path. How do we know Einstein's theory of general relativity is right? Do we have any specific evidence for it? Turns out, physicists have found tons of evidence to prove this theory. For example, one of the most famous pieces of evidence is gravitational lensing. Gravitational lensing is a tool used by scientists to study and understand the distribution of matter in our universe. It allows astronomers to view distant galaxies as they were in the past, and helps them gain an idea of how our universe was formed. The mathematics and physics behind this concept proves that any massive celestial object, such as a planet or a quasar, can bend any passing light rays. These celestial objects are said to warp the spacetime fabric, and it acts as a lens that bends and magnifies the light passing by it. This way, we are able to receive multiple images of the celestial object. There is also another effect known as the Shapiro time delay effect that confirms the theory of general relativity. We know that the Sun is extremely massive and a lot bigger than any of our planets. Therefore, it causes a bend in the spacetime fabric. Any light that passes by won't travel in a straight line, as it will bend as well. As a result, light from a planet on any other side of our solar system from Earth will reach us a little bit later than expected. Einstein's theory of relativity and gravity is actually a lot more complex. Although we have quite a few experiments proving his theories, we have not yet found all the answers. But it does give us a pretty good idea of how gravity works, and how our stars and galaxies were formed. If you learned something new, make sure to hit the like button and share the video with your friends. Subscribe for more daily content like this.